In this tutorial I'm going to talk about how to make a mesh in Comsol. The Comsol program has a lot of functionalities when you talk about mesh. The mesh will be found in this part here. Anyway, we should start with Model Wizard, 2D problem, electrostatics again. I'll take away. I'll go for study. I'll go for study. I have a stationary, so I started the program. I don't save that part, the whole part. Okay. I will in this tutorial assume that you have now an understanding that we need a refined mesh for some time. Particularly if we have a solution that is very, very intense, or the solution varies a lot on a corner or a part of the problem, that we have to we need to do a more accurate analysis there. We know now that small elements makes more accurate solutions if we don't do a mistake in any way, and we should use more of a coarse mesh at other places just to save computation time. So very often we will see a big variation in element size from the biggest to the smallest. Let me now simply draw some geometric elements here just to have something to play with. I start with a rectangular that I'm just doing like that, and I start with putting a other rectangular, and then I put in a line that goes like this, just to have some fun, huh? So in that case we have now chosen to put in some geometry elements that can actually make quite a difficult analysis, at least by hand, but also for the finite element solution. Let's say this was an electrode, this was also an electrode. Around this corner here could be very, very sharp. No, sharp. It would be a very big change in the elements. The end of the geometry part is actually very sharp. It's actually not a physical geometry because the line is infinitely thin, and it will make this point to be a singular point. So, well, we need that point to be very much focused on to see what happens around here. Anyway, let's simply make the program itself make a mesh as it would do if we don't say anything. We will have a normal mesh size, as we call it. We simply make a mesh here like this. And you see here in this case, the mesh is influenced by the line, because the line follows that mesh. The mesh follows the line. Also in this case, the boundary of that object is actually influencing where the elements are located. We can directly here then influence the mesh by saying finer, for example, and then use a build mesh there to see what happens. Well, this may be a good one. I don't know. I don't do an analysis now to check it out. What I would do, what I can do, is actually to influence more on this thing here if I in a way define the mesh more directly. So what I would do then, I would say no, I will define a mesh more specifically now, and then I say I would introduce a triangular mesh, and you see here automatically here the size and the free triangular is becoming nodes in that tree. Is this actually the same as before? We can just do a mesh command and it does the same thing. And we can go in here, we can change the mesh in the same way as we did up here earlier. I can make it coarser, and then I get the mesh like that. Still, this is influencing how the mesh is generated. The program has a kind of energy and distance evaluation, and this like automatically it makes smaller elements down here than up here. It finds this to be a good solution, but really the program don't know and the program is not very smart all the time. It's very often it is. So now we have a mesh that we may be happy with, but we can actually now go in and influence how that mesh is generated. Then I hit the free triangle here and I right click, so then I can say, well, I can make a new size function on that mesh again. Then I can actually, this first size here was like a general starting point. We can actually go in and then influence more on the sub level. And then we can go in and say here, well, we can look at a domain. Let's say we look at this domain here. Then it opens up to pick out or pick up elements to be put in there. So then I put here, because that is surface number 2. And then I actually can give commands to that size function. So I can say, we have picked it up manually. And then I go here for a normal, no, we should go for a finer mesh there. Let's try. So we have a coarse mesh out here, and then we put a finer one here, just to try. See? This one is now defined to be a finer mesh. I can go even more. So I want to extremely fine there. But it keeps the thing around here more as it was. It will influence a bit outside that element, but it's very fast, the elements, so they become big again. Maybe we should try something more. Maybe we should make another one that I would say is with size functions. We had 2 size influences, and this one here could be a boundary one. Then I pick this one here, pick that boundary to be influenced. So I can actually go there and also make a influence there. But in this case I would like to make a custom one. And this is not what I expected it to be, so maybe I was a bit quick there. So let me go back to this one here. Simply make it fine, just to show you here. So I can influence that line also. What I hoped to do here was to make a variable elements size. So I have to wait a bit with that. I think it's so easy. I can do like this. If I take away that one, and I say, okay, I take that away, and then I say I want a distribution here, and I want to go on that particular. Yeah, this is a boundary function, so I make a distribution like that. Okay, here I can have a fixed number along that line, or I can have a predefined distribution. So I have 5 elements along that line. That's not enough. I would pick 20, and then the elements ratio from the biggest to the smallest is 1 here. So that doesn't mean anything. So we should make 2, for example. And then you see here what happens. It's smaller here than here. This is 2 times as big as the smallest one. Well, I want to make it a bigger difference, so I go for 10. So then again, I can type build all. Oh, that's fun. Now I have squeezed the elements to go down here to become small here. We can check it out. See here, it's actually very small down there. If by chance this was not what I wanted, maybe I wanted the elements to be small up here, then I simply reverse the direction here and do a build all again. Comes up here. So that is how you can operate on the geometry here. I can also, for example, go in here now, because I'm still in that distribution. Maybe I find this of interest. Maybe I should operate like that. Oh, that was wrong. I didn't want that to be in this line, because it goes from here to here, and I didn't have a control there. I can actually find a little bit more control by looking at this view function here. I think it's someplace here, view. And I say I want to see the edge directions of the entities. So I simply do that again, and you see here I can look at the, the lines how they are defined from here to here, from here to here. So if I go back here again to that distribution, I can simply say, oh, reverse. If I want to have them here, I can do like that, and I say below. Oh, so then I got a lot of elements here. Maybe that's what I want. Yes. Let's go back again. I want to reset this element thing. Simply reset. It asks me what I'm going to do. Yeah, I want to reset it, and it has no elements now. But if I say build all, I get that very coarse and very rough element style here. I don't necessarily want to have this triangular mesh. I would like to try something else. I delete it so that I don't have a mesh anymore. This is no mesh. It says something about the size, but if I start to build all, it doesn't give me anything. So if I now put 3 quads here, I can put that in here so it comes on the right place again below the size function. Okay, again we can try to build all, and we will see a different element style. Everything disappeared now from these distribution of elements and so on. I can do that. I can add those functions, but I can wait a little bit. I want to go for a bit finer mesh. Maybe I should have a extra fine mesh. You will see that these quads are actually bigger for the same problem very often. So we have something like this. I don't know if this is a better mesh or anything like that, but I can then go for a distribution here. I would like to distribute it, and those are functions that you see here. I can also look for some other functions. Corner refinement. Oh, what's that? Maybe we should try a corner refinement. We say, oh, a corner refinement, and then I push 2 edges. See, boundary selection. I put 2 edges in which this is the entire geometry. I should push that first. And that's okay. We have only the entire to work on now. Then I go for a boundary selection. I say manual there, and then I push here to make it active. So then I say I want to look at this line and that line as a corner, and then I would like to see how the elements are varying along these 2 corners. And this is a ratio of 1 like 0.25, so the biggest one is 4 times as big as the other one. Let's try that one. Oh, you see, large elements, small elements, large elements, small elements. So that was a cornering effect. So that was one of those functions. We can have this general size function. We can have a distribution, and we can also have a cornering effect. Maybe we should have a distribution along that line again, as we tried earlier. So let's make that as a distribution. We make a variable distribution like that. So 5 elements, that's too small. I should say 15. It's 515, but 15. And then I would have a ratio of 1 to 7, for example. So let's try. Make it build. Yeah. Push the elements down here. Good. I'm pretty happy with that. So now I've learned you how to do this on both triangular elements and quads or quadrature elements.